Okay. So, next you see that electrical equivalent say of branch 3, each and everything you try to understand. This is applicable for lateral branches I have taken, applicable for main feeder or lateral branches does not matter, explanation will remain same. Now, if you consider electrical equivalent of branch 3, that means sending end node is 3, receiving end node is 4. So, this is 3, this is 4, current flowing through this branch is your I 3, right, because it is electrical equivalent, and total load is receiving end node is your 4. So, total load feeding through this node P 4 plus J Q 4. That means, if you consider this thing, then what is P 4? This is the receiving end node. What is P 4 and Q 4? The total load fed to this node will be P 4 will be P L 4, because whenever I am saying I 4 means P L 4 plus J Q L 4, loads are there. Earlier we have explained also taking main feeder, but here because of the space problem I have not shown, but understandable. So, P 4 will be P L 4 plus P L 5 plus P L 6 plus P L 9 and plus loss of the branch 4 real power loss, then real power loss of branch 5 and real power loss of branch 8. Similarly, your reactive load fed through this node, that is your Q 4 will be Q L 4, Q L 5 plus Q L 6 plus Q L 9 plus reactive loss of branch power loss of branch 4, branch 5 and branch 8, that is the total load fed through node 4. Similarly, if you come to your node your branch 4, say this branch, if you come to this branch, right, then is sending a node, just see it is 4 and receiving a node it is 5, this is 4, this is 5 and this is your P 5 plus J Q 5, that is the total load fed through this, and current flowing through this is branch 4, it is I 4 and impedance of this branch is I 4 plus J X 4. This is the electrical equivalent of branch 4. Everywhere I am not writing electrical equivalent, but understandable. So, this is your branch 4 electrical equivalent. So, that means what is the total load fed through the node 5? This is actually node 5. What is the total load fed? Node 5 is, that is P 5 will be P L 5 plus P L 6 plus loss of this branch only, because this is that your beyond this branch only this your what you call these two nodes are there. So, P L 5 plus P L 6 and loss of branch 5. Similarly, total load fed through this node will be Q 5 will be Q L 5 plus Q L 6 plus loss of this your what you call branch, right. So, that is actually you have to find out that what is the total load fed through each branch. Similarly, if you come to this is last one, suppose you take that node 5, that is that electrical equivalent of branch 5. So, it is 5, it is 6, total load here fed through this P 6 plus J Q 6 and current flowing through this is I 5 and impedance of this branch is I 5 plus J X 5, right. So, in this case, now this is actually last node, beyond this there is no other node or branches. So, what is the P 5? Then in this case total load fed, sorry, it is 5 6, what is P 6? Total load fed through this node P 6. P 6 actually is equal to your P L 6 and Q 6 will be just your Q L 6, right, because this is the last node. For example, here load is also there P L 6 plus J Q L 6. So, your P 6 in this case will be P L 6, right, or I can put it in bracket here also, if you want you can put it in bracket, and your Q 6 will be is equal to Q L 6, right. So, that means in this case, but no other branches. So, there is no question of adding branch losses. So, any node is coming at the last node, total load fed to the node is the load of that node itself. So, that is why for the last node P 6 and J Q 6. So, P 6 is equal to P L 6, Q 6 is equal to Q L 6. Similarly, if you consider the electrical equivalent of branch 8, it is the last node, beyond this branch there is no other branch, no node, right. So, in that case your P 9 will be P L 9 and Q 9 will be Q L 9. Similarly, in this case that branch 7, that 7 and 8, this is the last node. So, in that case P 8 will be P L 8 and your Q 8 will be Q L 8, right, because there is no other branches. So, no question of losses, this is only for the last node, but all other cases if you take your electrical equivalent of branch 2 to 7, then P 7 will be PL 7 plus PL 8 plus loss of branch 7, real power loss. Similarly, total load fed through Q 7 will be your QL 7 plus QL 8 plus reactive loss of branch 7, right. So, this way you have to find out what is the total load fed through each node, right. So, I hope this is this concept is understandable to you, because here concept is more important, mathematics is simple, but concept is more important. So, now here if it is electrical, now you come to this figure, that electrical equivalent of branch 1, because we have to find out some mathematical relationship of V2 voltage V2 and V1, because our objective is to eliminate the angle delta from the mathematical expression. Actually, a similar expression was given, I think, in the very first topic, that this kind of expression, and I ask you to derive the expression of the receiving end voltage magnitude. Same thing here we will make it now for the purpose of this load flow, as well as later step I will tell you regarding that voltage stability, right. So, same thing actually I gave you, that as an analysis this thing. Many of you did it and send it to me through email, and I found all of you made it correctly. So, look how I have made it here, right. So, this is sending end voltage, of course, it is equivalent branch 1, but for generalization we will keep V1 delta 1. V1 is the voltage magnitude here. So, again and again magnitude I will not utter, and this is V2 angle delta 2, this is the branch current I1, and this is your impedance R1 plus jx1, and this is total load fed through this node 2. When we will take the numericals, a small numerical, at that time whole concept will be very transparent to you. Now, P2 is equal to total real power load fed through node 2, right. Similarly, Q2 is equal to total reactive power load fed through node 2, right. This is Q2. Now, what is P2? Just I told you that P2 is equal to sum of the real power loads of all the nodes beyond node 2 plus the real power load of node 2 itself. I mean, I told you beyond this branch you sum up all the loads beyond node node 2, that means this node, this node, this node, this node, this node, this node and this node, plus the node of the node 2 itself, that is your PL2. So, that is why sum of real power loads of all the nodes beyond node 2 plus the real power load of node 2 itself, plus you have to go for adding this branch losses, this branch, this branch, this branch, this one, this one, this one, this one and this one. So, in general, plus the sum of the real power losses of all branches beyond node 2, that means beyond this node 2 whatever branches are there, you have to add their real power losses, right. So, this is actually total load fed through node 2. What is losses, how to compute, later will come. Similarly, Q2 is equal to sum of reactive, meaning is same, only instead of real power we will replace the word real by reactive, rest is same. So, Q2 is equal to sum of reactive power loads of all the nodes beyond node 2 plus the reactive power load of node 2 itself plus the sum of the reactive power losses of all branches beyond node 2. That means, same as before. So, this is your total load fed through reactive power load fed through node Q2 is equal to sum up all the reactive load of all the nodes plus reactive load of the node 2 itself plus all the reactive power losses of this branch, this branch, this branch, this branch. I mean, beyond this node 2 whatever number of your what you call or beyond this branch whatever number of your nodes are there, you branches are there, just you identify and add their losses with that. Therefore, that is your Q2. Now, here for load flow studies, here we have to make little bit of different. In this case, we have seen that how many nodes are there beyond each branch, right. Now, we have to find out how many nodes are there, branches are there also beyond your each branch, then our job will be simple. So, for this, for the same diagram, right, such that your what you call same diagram I have taken, such that it will be easy for you to understand. These are the branch number, there are 1 to 8 branch number that we have seen. Sending on node M1 is equal to ISJJ, M2 is equal to IRJJ, that we have seen 1 to 2, 2 to 3, 3 to 4, 4 to 5, 5 to 6, then 2 to 7, that is your 2 to 7, 7 to 8 and then 4 to 9, 2 to 7, 7 to 8 and 4 to 9. This we have make it. Nodes beyond branch JJ, all these things have been explained in the previous table and detail explained. These are the nodes beyond branch JJ. So, beyond each branch how many are there? Here it is there. Same thing I have copied it here, same thing here, and number of nodes beyond each branch here also given 8, 5, 4, 2, 1, 2, 1, 1. Here also same thing, up to this it is same, right. After that, branches beyond branch JJ, that means beyond this each branch, for example, beyond this branch how many branches are there? Their numbering and their total number of branch and their numbering, branch number and total number, right. Beyond this branch how many branches are there? Because why do we need the branches? Because we have to identify the branches beyond each branch, because we have to find out the power losses, real and reactive power losses in each branch. That is why it is your what you call, you have to know the branches beyond each branch, right. So, that is why this another 2 columns have been made. So, for example, branches beyond branch JJ, right, when branch JJ is equal to 1, branch JJ is equal to, these are the branches beyond the bracket, that is in red color, 2, 3, 4, 5, 6, 7 and 8, right. These are the branches. So, 2, 3, 4, 5, 6, 7 and 8. Then beyond branch 2, what are the branches? Branch 3, 4, 5 and 8. So, beyond this branch 2, these are the branches beyond branch 2, 3, 4, 5 and 8. Similarly, beyond branch 3, that means your this branch, beyond your branch 3, here it is how many branches are there? 4, branch 5 and branch 8. So, beyond branch 3 it is 4, 5 and 8, total branches is 3, previous case it was 4 and first one it was 7, right. Similarly, beyond the next is beyond branch 4. So, this is your branch 4, beyond branch 4 how many branches are there? Only one branch is there. So, this is branch 4. So, come to that, only one branch is there, its number is branch 5, this is branch 5, right, and only one. So, it is 1 here your what you call, here it was given NJJ, that is the number of nodes beyond branch JJ, here space was not there, I did not write, but NJJ is explained before, same thing, right, same thing. And this is total number of branches beyond branch, that is BJJ we are making it, right. Similarly, if you come to your branch 5, then it is 5 to 6, then what is beyond this branch? There is no branch, actually 0. That means, if you come to branch 5, there is no branch, so it is 0. So, number of branches also 0. Similarly, if you come to branch 6, 2 to 7, that is your 2 to 7, there right, this is the branch. Beyond this branch only one branch is there. So, 2 to your what you call 2 to 7, that is branch 6, 7, 8, there are 2 nodes, 7 and 8, 2 nodes, and only one branch, that is your branch 7. So, BJJ is 1, right. Similarly, if you consider branch 7, that means this branch, beyond this branch there is no branch, that means 0 branch, that means BJJ will be 0. So, if you look at branch 7, it is 7 to 8, up to this is known, all this up to this was there previously, but as beyond this branch there is no branch, it is 0, therefore, BJJ will be 0. Similarly, if you come to last one, the branch 8, that means this one, beyond this branch there is no branch, right. That means BJJ here also will be 0 and number of branches also 0. So, therefore, it is if you come branch 8, branches beyond this branch 8, it is 0, therefore, BJJ is 0. That means, this additional table you have to make it for the second method of the load flow. This one will remain as it is, but these 2 additional data you have to feed to the computer, right. But this branches identification, node identification, all algorithms are available, but I thought rather than that one, this will be very easy for you to understand, right. So, if you want how to identify, you can think and you can make the algorithm, but here I am not trying it, right. There are couple of algorithms are there that how to identify the nodes or the way you want, but here these are the data, I mean for this load flow second method, all the data you need to feed into the computer, right. So, this is your total load fed through any node concept, right. Therefore, for this case EJJK, that is matrix will remain same. This EJJK matrix we have previously defined for JJ is equal to 1 to up to Ln, the total number of your branch number, and for K is equal to 1 to NJJ. This EJJ matrix will remain same, and we have seen how to make it, right. Now, this one we have to see for branches we will define a matrix say FJJL, right. We will define a previous one was your EJJK and this one is the matrix F j j L. For j j is equal to 1 2 up to branch number Ln, and L is equal to 1 2 up to your B j j, that means this one, that means your this one, this data you have to feed to the computer, that means this one, this B j j, right. This one you have to make it in the tabular form, right. Therefore, so for the other matrix F j j L L, therefore j j is equal to 1 to L n, right, and L is equal to 1 2 up to B j j. So, for example, when j j is equal to 1, suppose when branch number j j is equal to 1, B j j is equal to B 1 is equal to 7. Therefore, B j j is equal to B 1 is equal to 7, that means for j j is equal to 1, it will be F 1 L, right, and L will vary from 1 to your 7. So, you can make it that F 1 1 is equal to 2, here it is given F 1 is 2, F 1 2 3, F 1 3 4, F 1 4 5, F 1 5 6, F 1 6 7, and F 1 8 is equal to F 1 7 is equal to 8, right. So, this matrix 2 3 4 all you have to read it, that F matrix, this data you have to create and you just put it in computer, this data you have to make it. Similarly, when j j is equal to 2, right. So, M 1 is this thing, your total number of branches beyond branch 2, it is basically 3 4 5 8, and B j j, that is B 2 is equal to 4, right. That means your just hold on, this one, after I think this one I have explained later, here I have made it, I have explained it later. Before that, what I have done it, that total load fed through this your what you call fed through this node P M 2, this expression I first I have shown this one. So, F 2 2 I will come, your F 2 L matrix I will come later. So, this P M 2, that is the total load fed through receiving end node. So, M 2 is equal to I R j j, this way you write, K is equal to 1 to N j j, P L E j j K matrix. Earlier we are writing I E j j K, that for first method. In this case, P L E j j K plus L is equal to 1 to B j j, the number of branch, P loss F j j L, this is equation 38. This equation will be slightly changed, first you understand, then this equation will be slightly different, right. Similarly, total reactive power load fed to the receiving end, it is generalized equation, Q M 2 is equal to, if it is I R j j is equal to j j 1, then M 2 will be 2, right. So, in general, Q M 2 is equal to I R j j is equal to K is equal to 1 to N j j Q L, in bracket you put E j j K, this matrix element will remain same as before. So, no, I am not explaining this one, right, plus L 1 L is equal to 1 to B j j Q loss F j j L, this is equation 39. For example, this element we have taken F 1 1, F 1 2 and so on. So, when j j for j j is equal to 1, branch 1, M 2 is equal to I R j j is equal to I R 1 is equal to 2, this is the receiving end node, this is the receiving end node M 2, it is equal to 2. Therefore, your what you call an N j j, N 1 is equal to 8, from this table we have seen that N your N j j is equal to 8, this is for your N 1 is equal to 8 in this case, right. And similarly, your for j j is equal to 1, B 1 is equal to 7, B j j is equal to B 1 is equal to 7. Therefore, B j j is equal to B 1 is equal to 7. Therefore, this expression when M 2 is equal to 2, P 2 is equal to K is equal to 1 to N 1, because j j is equal to 1, N 1 is equal to P L E 1 K. This will be similar to your previous load flow method, only instead of I it is P L, right, plus your L is equal to 1 to B 1, B 1 is equal to 7, P loss F 1 L. Now, you expand this, right. If you expand this, what will happen, this one same as before, it will come 2 3 4 like this. So, directly I am writing P L 2 plus P L 3 plus P L 4 plus P L 5 plus P L 6 plus P L 7 plus P L 8 plus P L 9. This is I am writing directly, plus this F matrix, when you expand this, it will be F 1 1, F 1 2, F 1 3 and so on. So, here all these elements I have given you F1 2, F1 2 3 and so on. So, if you expand and substitute all this, it will become P loss 2 plus P loss 3 plus P loss 4 plus P loss 5 plus P loss 6 plus P loss 7 plus P loss 8. One step I have just not written, because earlier this way I have explained for I. That means, in this case, for example, in this case your if you expand this, if first term will be P loss in bracket F11, but your F11 2 it will be P loss 2, second term will be your P loss F12. So, F12 is 3, so it will be P loss 3 and so on, right. That is why it is P loss 3 and so on. This is equation 40. Similarly, for equation 39, Q2 will be QL2 plus QL3 plus QL4 plus QL5 plus QL6 plus QL7 plus QL8 plus QL9 plus all the branch accordingly will come Q loss 2 plus Q loss 3 plus Q loss 4 plus Q loss 5 plus Q loss 6 plus Q loss 7. This is equation 41. Now, for JJ is equal to 2, now we will come to that. For JJ is equal to 2, that means this branch, right. For JJ is equal to 2, right, your M2 is equal to 3, receiving end node, that is for JJ is equal to 2, M2 is equal to 3, because it is M2 is equal to IR2 is equal to 3. So, M2 is equal to 3 and NJJ is equal to N2 is equal to 5. This is already there, this we have done same as before, but for the branches it will be branches beyond. There are 4 branches 3, 4, 5, 8 and BJJ is equal to B2 is equal to 4. So, BJJ is equal to B2 is equal to 4. Now, FJJ matrix L means F2L and your L varying for L is equal to 1 to 2 B2, that is 1 2 3 4, there are 4 elements. So, F21 is 3, F21 3, F22 4, F23 5 and F24 8, right. So, these are all 4 elements. So, that means from equation 38, that means this equation directly you use this value, that this equation, right. After this we have given the generalized equation for this one, this this equation 38, this is equation 38, right, equation 38. Similarly, this equation 39. So, equation 39 you put those things, you will get P3 is equal to PL3 plus PL4 plus PL5 plus PL6 plus PL9. At the same time, you look at your what you call the diagram figure, that whatever from figure you have taken, and you verify plus P loss 3 plus P loss 4 plus P loss 5 plus P loss 8. This is equation 42. Similarly, from equation 39, Q3 is equal to QL3 plus QL4 plus QL5 plus QL6 plus QL9 plus Q loss 3 plus Q loss 4 plus Q loss 5 plus Q loss 8. This is equation 43. This is for branch your what you call branch 2, and for JJ is equal to 3, branch 3 M2 is equal to IRJ is equal to IR3 is equal to 4. That means, for branch 3 your receiving end node is 4. These are same, here you have 3 nodes beyond branch 3 and total branch is 3. So, BJJ B3 is equal to 3, right. So, in this case also M2 is equal to 4, N3 is equal to M2 is equal to 4, N3 is equal to 4 and your BJJ is equal to your B3 is equal to 3. So, FJJL, so JJ is equal to 3, F3L matrix for L is equal to 1 to B3, that is just 3 elements 1, 2 and 3. So, no need to put comma here, it is 3 elements only. So, no need to put it dot dot dot. So, 1, 2, 3, 3 elements are there, right. Therefore, P4 will be using the same again from equation 38, this P for equation 38, Q for equation from equation 39. So, P4 is equal to PL4 plus PL5 plus PL6 plus PL9 and plus P loss 4 plus P loss 5 plus P loss 8, right, and these elements are given here, F31 is 4, F32 5, F33 8, it is given here, this is 4 5 8, these 3 elements are here, right. Similarly, Q4 QL4 plus QL5 plus QL6 plus QL9 and this one plus Q loss 4 plus 3 branches are there 4 5 and 8. So, Q loss 4 plus Q loss 5 plus Q loss, this is equation 45 and this one equation 44, right. So, from this I mean I hope this thing is very easy for you to understand, right. Similarly, when JJ is equal to 4, not going to the diagram again and again, because this is understandable now. M2 receiving end node is 5 and NJJ N4 is 2, same as before, and in that case BJJ B4 is 1, that is only one element, right. Therefore, FJJL F4L, so L is equal to just 1 to B4, so it is only one element and else is equal to 1, therefore F4 1 is equal to 5. Therefore, from equation 38 P5 is equal to PL5 plus PL6 plus P loss 5, this is equation 46, and from equation 39 Q5 is equal to QL5 plus Q loss 6 plus Q loss 5. This is so from this F matrix branch you can see that how important it is and how it is easy it is to find out all the load fed to the node receiving end node of each branch, right. Similarly, when JJ is equal to 5, M2 is equal to IRJJ IR5 is equal to 6, so NJJ is equal to N5 is equal to 1. So, BJJ is equal to B5 is equal to 0, that is no branches beyond this. So, that means P6 I just showed you before also I explained you that P6 will be PL6, Q6 will be QL6, this is equation 48, this is equation 49, because there are no branches beyond branch 5. So, it will be like this. So, in this case B5 is 0 means that second term of equation 38 and 39 will not exist and only single term, I will come to that later. When JJ is equal to 6, M2 is equal to your IRJJ IR6 is 7 and NJJ is equal to N6 is equal to 2, this is same as before, and BJJ is equal to B6 is equal to 1, from the table only you can check, right. So, FJJL is equal to F6L, that is L is equal to 1, so only one element F61 is equal to 7. Therefore, P7 is equal to PL7 plus PL8 plus this P loss 7, because this element is 7 branch, this is F61 is 7 branch 7. So, and Q7 is equal to your QL7 plus QL8 plus Q loss 7. So, this is equation 51. These two equations are same, this is for P and this is for Q, but addition everything remains same, right, same term. When JJ is equal to 7, so M2 is equal to IR7 is equal to 8, this is that your last branch of lateral branches, NJJ is equal to your N7 is equal to 1, right, and your BJJ is equal to B7 0, because beyond this branch there is no other branch. So, P8 will be equal to PL8 and Q8 will be QL8. So, second term of equation 38 and 39 will not be there, because there is no other branch beyond this, right. And when JJ is equal to 8, the last branch, M2 is equal to IRJJ is equal to IR8 is equal to 9, right. That means, this one showing once again, that means this branch, and in this case also N8 is 1, NJJ is equal to N8, BJJ is B8 0, because beyond this branch also there is no branch, right. Therefore, P9 I told you, P9 total load fed to the will be PL9 and Q9 will be QL9. So, Q9 will be QL9, this is equation 54 and this is equation 55. So, thank you, we will come.